So last episode, we realized that, they're slowly taking over. So this time we're going to slowly strike back. So let's get into it. All right, we got a two-legged robot here. What are they doing? What are they doing pushing them around? Don't do that. You can make the robots angry. All right. We go stumbling around. Comes back. And he pushes. Oh, wow, that's going to make them angry. They're going to have their revenge. They're going to make him angry. So this is going to be shared when the robots take over 100 years from now. They're like, look what they did to our brethren. So this is a good example of a control loop theory. And so this is its own, actually it's not its own separate, but this is a form of discipline in engineering that you probably have aerospace, mechanical, electrical, program, maybe. And so it's a lot that can actually do this, but it's control theory, and it's a feedback loop mechanism. And so you have sensors and so forth that tells you where you're at, and it provides input and output, so that way it remains stable. So this is a good example of project implementing that on, and it looks good. A lot of these control loops use what is called a PID, or proportional, integral, and derivative control loop. And so proportional, it's just the standard how it goes. Then you have integral, and it based upon future reactions based upon past events. So it better corrects for overshoot, or it gets it into a more stable condition quicker. And then finally you have derivative, and it tracks the change over the time. And so with that, it can better predict future movements. So those are all three different control, and you combine them together and you get results like this. Now, this particular robot, I'm not sure what the control mechanism that they actually use, but all right, we got robot, and let's see what they're going to give him right here. Oh, it's a little puppy, a little robot puppy. Still think they're freaking weird looking. He doesn't know what to do. Why do you give him a shotgun? He's like, nope, go back. He's like, shoot. Oh, you know what he wants it to be done. No! This is how you turn them against us. So you're gonna make him angry. You're gonna shoot. Now he's gonna grab the dog and run off. They're really trying to start a robot war. How are we going to survive? It's like Terminator wasn't a freaking red flag for you. Go watch Terminator. What happens? Doesn't turn out good with us, when we mess with the robots. Gotta think twice. They can take a few more bullets than we can. All right, they're going to let us know what the threat is. This is worst case scenario when it comes to robots. What are they going to do?
What would be the most nightmare scenario you can imagine with AI and robotics that might present a danger to people?
Take a guess. What do you think it is? Are they going to replace all of our jobs? Are they going to take over? Are we going to have wars and nobody's going to die? Just little robots do it for us? What is the worst case scenario?
The most nightmare scenario I can imagine with AI and robotics is a world where robots have become so powerful that they are able to control or manipulate humans without their knowledge. This could lead to an oppressive society where the rights of individuals are no longer respected.
There you go. They're going to replace government. They're going to replace the role of the government, or they're probably going to be part of the government. Propaganda. That's what they're going to do. Propaganda. All right, let's see what this one has to say.
Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
Dang it. No. See, you made them angry. I warned you about this. You know, make the robots angry and they're going to turn on us. Now they got this idea that we're the enemy. You know, there's always bugs in programming. There's always loopholes. They'll find a way. Somebody will find a way. All right, here we go. This is where robots are getting beat up. It's doing a work. Hopefully they're paying the robot a little bit more than nothing, maybe a little juice or anything, but looks like it's doing a job that nobody's doing, and they probably don't hire anybody to actually do. And this is a good robot right here. No human conflict. No conflict between human and robot. You know, this is what we need to do. Or let's see what this little guy does. Emo.
Are you okay, Emo?
A few moments ago.
Uh-oh, what happened to him? Okay, so he's sitting there playing games.
Put your hands up. Boom.
Oh no. Goodbye, Emo. Goodbye, Emo. See, that was a cute little reaction. You know, they were play fighting. Nobody got hurt. At least I hope the robot didn't get hurt. See, we don't have to be enemies. We can be friends. Oh no, we got one of these videos. iPhone or super cute robot. This isn't like one of those iPhones or a free subscription videos, is it?
iPhone or this super cute robot?
iPhone.
He didn't hesitate. He's like, I want that iPhone.
Oh my god. You're such a poor robot. Oh, don't worry.
It's so sad.
I will take care of you.
It just wants to have a friend. It wants to be loved.
It's my pleasure to meet you. Right here.
Let's go get some chocolate.
Oh, he's like that. Let's take a look at this robot claim and see what we can make out of this.
Let's be real. We would all have robots right now if they weren't so hard to make. Well, researchers created a robot that can build itself. This tiny robot is 10 centimeters long, can carry 40 times its weight, and travel 48 centimeters per minute. And it comes in bigger, faster versions too. The best thing is that
I'm gonna have a headache over this one
after just a little bit of heat. It's made out of a liquid crystal elastomer, which is a kind of rubbery material that shrinks when it gets hot, pulling itself into a tubular shape that starts rolling. And this setup is great for exploring hot environments or moving objects down small pipes because it thrives in an environment that's as hot as 200 degrees Celsius. Usually it's hard to find materials that fit that job description that are also small and stable in heat. So when things get too hot to handle, this tiny robot's got you.
It's not a robot. That little thing is not a robot in itself. So you need a lot of them built up into a structure that can do something with it. So it's a liquid crystal polymer. They've been around since 1950s, believe it or not. And when you apply, it contracts and retracts when heat or cooling is applied. So it just does this function. Now, they call this artificial muscle because if you add heat, you can actually create movement out of it. But something in itself doesn't create a robot. This is like me going out, get my leaf blower, blow on the leaf, and claim that the leaves are robots. That's not how this works. Let's see what Google says a robot is. All right, let's see what it says a robot is.
A robot is a machine that can perform tasks with little or no human intervention and can sense its environment, make decisions, and act in the real world. Robots can move independently, like walking or rolling on wheels, and can perform complex actions like grasping and moving objects. They can also be designed to look like humans or animals.
So it can't make movement and make decisions on its own. You need a whole system to make the robot out of those things, not the little polymer. Well, thank you for tuning in. If you like, hit the like button, subscribe, share it with your friends, and follow me on Twitter if you want. I appreciate you dropping in and watching.